This is practice problem 3 in your work packet. You need to find all the external and internal forces of this truss. We always start with the external forces first. So pause the video and draw the free body diagram for only the external forces. At joint A, there is an external force of 100 pounds given. Joint C, there is a pin. Pins can have two forces, one going in the X direction, one going in the Y direction. Because joint A has the external force going downwards or south, joint C, the vertical component must go up to oppose A. It also has a CX, and since we don't have any other external forces given, we are going to just make it go to the right. And again, if your direction is wrong, it will come out negative and you could correct it. Joint D, there is a roller present. First thing we do is we locate the surface. The surface or ground is vertical. Therefore, the force must be perpendicular to the surface, so we can only have a vector in the X direction. Since we stated that CX is going to the right, to oppose that, DX must go to the left. We must select the pivot point. The pivot point is the point in which there is the most unknown. This is joint C. Now I write a sum of moment equation. It has to equal to 0. The possible moments are moment of A plus moment of B plus moment of C plus moment of D. So this has to equal to 0. Automatically, I could cancel out moment of B. There is no external forces provided. Therefore, it's just 0. Moment C is also 0. Remember, the formula for moment is force times displacement, and the force and displacement must be perpendicular. Since the displacement is 0, because that is my reference point, a 0 times force is going to equal to 0. So my formula becomes FA dA plus FD dd. This is equal to 0. We know that FA is given as 100 pounds. The direction or the distance must be perpendicular. So if this is my pivot point and my force for A is going downward, my distance or my displacement has to be horizontal. So this is going to be 7 feet. My FD is dx, and my displacement is the following. For D, my force is going to the west, perpendicular to my C must be vertical displacement, which is 5 feet. So my DD is going to be 5 feet. I account for direction as I move along. So if I look at this, this is pivot point C. The force is pushing down on it, so this is going to rotate counterclockwise. By convention, counterclockwise is positive, so this is positive. For this one, the second one, this is pivot point C. This is my dx. If I push on my dx, it's going to make it rotate in the clockwise direction, so this one is negative. So now I'm going to simplify. So 100 times 7 is 700 equals to, since this is a negative, I move it to the other side, it's positive. So it's 5 dx. dx becomes 140 pounds. It came out positive, so my direction that I drew in is correct. Next, we must write a sum of Fy. My sum of Fy must equal to 0. We have Cy going up. This is opposed by A. This is must equal to 0 or the structure will twist. So that means Cy is equal to A, and A was equal to 100 pounds. And since it came out positive, I know my direction is going up. Next, I write a sum of Fx. This is going to be dx is to the left, so we know Cx is going to be positive minus dx. This has to equal to 0 to be at static. So Cx is going to be dx, and dx we solved as 140 pounds. It came out positive, so I know my direction is correct. So now I solved all my external forces. Now I need to work on my internal forces. When we determine the internal forces, we need to account for the beams. So first, we have to select a joint. The easiest joint is joint C because there is no angles. So the first thing you're going to do is you're going to draw a free body diagram. You're going to draw a free body diagram to include the external forces and the internal forces. So at joint C, we already know Cy goes up because we solved that, going up. You know Cx goes to the right. Since we have a beam CD, so at joint C we have a beam CD and we have a beam CB. To oppose CX, that means CB must go to the left. To oppose CY, it has to go, CD must go down. If not, the structure will not be at static and it will twist. So now I write a sum of Fy and a sum of Fx. My sum of Fy is equal to Cy because it's going up minus CD. This is equal to 0. So CD is equal to Cy. And we solve Cy as 100 pounds. And since it came out positive, I know the direction that I drew CD is correct. Now I write a sum of Fx. So Cx minus Cb, this has to equal to 0. So Cb must equal to Cx, and we calculated Cx as 140 pounds, and that went to the left, and it came out correctly because it is positive. So now I'm going to put the direction in as I move along. So CD is going down. So I know CD is going down. And we know this is 100 pounds. We also know CB is going to the left at joint C. Therefore, we calculated this as 140 pounds. So at this point, we have 3 more beams to calculate. Now we're going to move to joint D. The first thing you want to do is draw the free body diagram. We know that at joint D, dx goes to the left because it was calculated with the external forces. There are 3 beams here. We have a beam that is going up and down. This is DC. We know the direction of DC because when we calculated joint C, we realized that CD went down, and so DC must oppose it in the opposite direction, so it must go up. That's going to be DC. We have two other beams. We have a beam that goes diagonal, which is DB. And then we have a joint that is going horizontal, which is DA. So we already know that DC is going up. The only other joint that could offer a counterbalance to DC is DB. So if DC is going up, DB can either go northwest or southeast. Since it has to oppose DC going north, it has to go southeast. And then we have one other beam, which is DA. This one, you're just going to arbitrarily assign a direction because we have vectors in both the x and y direction. We have one going into the left at dx, and we have the component of dB is going to the right. So dA, I'm just going to make it go to the right, and if it comes out negative, we know we put it in the opposite direction. So after I draw my free body diagram, any vector that is at an angle, I must resolve into x and y. So if I look here, the vector that is at an angle is DB. So the first thing you want to do is draw a right triangle. So this is DB. I'm going to take that vector, it's going to go south, and it's going to go to the east. This makes a right triangle, so DB becomes a hypotenuse. This angle was given to you in the worksheet as 35.6. Since right here is next to, so my dBx is going to be dB cosine theta. Remember, next to is always cosine. The y, which is dBy, is opposing the theta, so that's going to be dB sine theta. So now you're going to write an Fy equation, or to make it a little bit easier, I'm going to redraw the vectors for you. So we know DC is going up. We know DX is going to the left. We know DA is going to the right. We know DBY is going south. And we also know that we have another vector, DBX, going to the right. So now I'm going to write my sum of Fy. My sum of Fy, DC is going up, so I'm going to write DC positive, opposed by dBy. This is equal to 0. So I'm going to rearrange this. dBy is equal to DC. And what is dBy equal to? dBy is equal to dB sine theta, which is equal to DC. I'm going to divide both sides by sine theta. The sine thetas on the left cancel out, so dB is equal to DC sine theta. And we calculated DC as 100 pounds divided by sine 35.6 degrees. And if you calculate it correctly, you get 172 pounds, and that is going southeast. Came out positive, so our direction is correct. So we can mark it on our beam that it is going southwest, or I'm sorry, southeast. Now I'm going to write a fx equation. Sum of fx is equal to dA. I'm going to make going to the right positive. if you notice, we have two vectors going in the right direction. So I have to add dA to dBx opposed by dx, which is equal to 0. I'm solving for dA, so I'm going to move everything to the right side. So dx minus dBx. So if I substitute this in, dx minus dBx was, remember, dB cosine theta right here. So I'm going to punch this in. I'm going to plug in the correct number. dBx we calculated as 140 pounds minus 172, because we calculated dB right above here, right here. Cosine 35.6 degrees. If I calculate all of this, this becomes approximately 0.038 pounds, which is pretty much equal to 0. So what that means is we do not need dA. dA is a useless beam. It's a waste of a beam. They didn't need to put that in there. So now we have pretty much all the beams except for AB. So I need to solve for joint A. You could do B, but it has a vector at an angle, versus A, there is none. So to solve for the last beam, we're going to select joint A and draw a free body diagram. So my free body diagram will be A going down, because that was given to you. We don't have a AD, but let's say I drew in AD, and I may arbitrarily assign going to the right, or I can make it left. So that means beam AB must go up, because we already know that A is going down and AB is the only beam that could oppose it. So I just drew in AD to show you why the joint is D. At D is also equal to 0. Remember, we have to do a sum of fx and a sum of fy. So in the x direction on my free body diagram, we only have AD. So if it's at rest, it has to equal to 0. So I could verify that DA and AD are both equal to 0. So this is why this beam is not necessary. In the y direction, we have AB going up, opposed by A going down. This is equal to 0. So AB has to equal to A, and A is 100 pounds. And it came out positive, so I drew my vector correctly, the direction. So I'm going to mark it on my paper. And if you notice, it's at this joint. AB is pulling it away. So that means at B, it must also pull it away. If not, the beam will break. Remember, they have to go in opposite direction. Since it's pulling the joints away, this is in tension. So if I look at BD or DB, we know that it is pushing into the joint D. So that means it has to also push into B, because they have to oppose each other. So this beam is in compression. We know that CD is being pulled away from joint C and D, so this is in tension. And BC at joint C, the beam is being pulled away, and so it must be pulled away from B, because they have to go in opposite direction. So this is also in tension. So if you're getting confused, pause the video at the beginning, and at each joint, draw your free body diagram, write your equation, solve, and then start the video, check your answer, then move on to the next joint until you understand it.